Assalamu alaikum. Here is my channel of nuclear physics. I am here to discuss nuclear physics with all you people. Now I am going to start my topic of radioactivity. We will start our nuclear physics with the radioactivity. First, we have the introduction of radioactivity. Radioactivity was discovered by Henry Becquerel in 1896 when he found that double salts of uranium and potassium, was the first elements from where we discovered the radioactivity, uh, and which produced dark images on the photographic plates on development event. ठीक है, and then Marie Curie and Pierre Curie confirmed in 1898 the theorem salt. Polonium and radium also emitted highly penetrating radiations. Such radiations were observed to be unaffected by any physical changes like application temperature, pressure, and electrical magnetic fields to the material. Such a radiation was found to be highly penetrating and could produce ionization in gases. The emission of these radiations from a number of elements take place due to disintegration of nuclei and called radioactivity. Means what is radioactivity? Radioactivity is the disintegration of the nuclei or nuclear elements. The elements of emitting such a radiation are called as radioisotopes. These elements are called radioisotopes. If the emission of radiations take place due to disintegration of naturally occurring heavy elements, it is called natural radioactivity. Because we have two types of radioactivity, natural and artificial radioactivity. If emission of radiation takes place due to disintegration of naturally occurring heavy elements or radioactive elements, we can called natural radioactivity. Or if the radioactivity occurred due to artificial transmutation of elements in the laboratory, then it's called artificial radioactivity. Rutherford discovered in 1899 that radiation emitted from radioactive elements consisted of positively charged alpha rays identical to helium nuclei and negatively or positively charged beta rays which have been identified with electrons. Willard shows in 1909 that another radiation called gamma ray was also emitted, which was highly energetic electromagnetic radiation. We have seen that when the radiations are emitted, then alpha particles and beta particles are alpha particles attracted towards the magnetic field and electric field, beta particles towards the magnetic field, and gamma particles were uh, uh, not attracted by any field and they were straight lines. And it is written toward positively charged alpha particle. Positively charged alpha particle and beta particle are deflected towards negatively charged plate, and gamma rays remain undeflected because they are electromagnetic in nature and do not carry any charge. Then the properties of radioactive radiations. These are the properties of radioactive radiations, that their penetration. What is their penetration? They are positively charged, negatively charged, or their deflection, and their process of fluorescence, phosphorescence, and effect on photographic plate. What is the effect? And backscattered by thin platinum film. सबसे पहले जो है, an alpha particle has a mass of this positive charge equal to this mass. It was mass number 4 and charge number 2 because it's the mass of helium nuclei, and alpha particle is the particle which is the helium nuclei. And then these particles formed in the nucleus due to binding of two protons and neutrons are emitted out of the nucleus with finite probability. These produce dense ionization in gases about 100 times greater than that of beta particles. Alpha particles are greater in ionization but have smaller penetration power. Gamma has less ionization, greater penetration. You can remember the properties of particles by by the for the of the particles. Alpha particles as well are positive charged particles are deflected by the electric and magnetic field. Both electric and magnetic field, but the most field, but deflected by both electric and magnetic field, as I previously called. Gamma are not affected by the electric, but beta particle and alpha. Then alpha particles produce fluorescence and phosphorescence phenomena. These produce scintillations. Okay? They feebly affect ordinary photographic. Alpha particles get back scattered by thin metallic foils. Rutherford estimated the nuclear size to be in range of 10 raised power minus 14 to 10 raised power minus 15 meter from the property of scattering of alpha particles. So this was the topic of our today's discussion. We will next discuss beta particle property, particle property. That's it. Okay. Thank you for watching.